Hello, I'm going to show you how I would create a stand for an STL model that's kind of tall, and you want there to be a recess or a carving for that model to be shoved into. I'm doing this because there was a recent question on the V1 Engineer forum. Andrew was doing such a project, and I made a mistake, and it was late at night, and I thought he was doing something else. So I ended up giving a completely wrong answer. So I want to kind of make up for that. But also the project that he's doing is kind of interesting, and I'd like to figure that out as well. So I'm going to show you how I would create a stand using Fusion 360. And I'm hoping this will help people, but also if there's a better, faster way to do things, I'm hoping someone will give me some feedback to help me and other people too. Thank you. All right, so the project that we're going to be doing here, this lithophane, I'm not going to go into what a lithophane is exactly, but what we are going to take is an image and convert the colors of that image into some kind of height material or bumps or an embossing that's proud of the stock or surface. And we're going to use this tool here. It's free, open source, that you can use to take an image, and this was shared by Andrew and others on the forum. Take an image, in this case I've got my Cat Mercury, and we'll get an embossed version of Mercury. Now the default settings for this model, I've been playing around with this and it looks like it remembers the settings that you have, but the default resolution vectors, the number of triangles that are created for every pixel of the image, I think it defaults 2. So when I go back to the model and do a refresh, yeah, you see that the model is now a lot more detailed, a lot finer resolution, which is great if you're using a fine tool or a laser or something like that to turn this into a real thing. Now the model, the lithophane that I think Andrew is wanting to work with, is going to be more of this kind of shape, which arguably could stand up by itself, but hey, why not make a stand for it to go in? And something to be aware of is when you do play around with these model settings, I think by default there's no border. And if there's no border, what you're going to find when you generate the model is potentially, depending on what your image is, you're going to have no gap here at all. And so since we're planning to create a stand where this model will get recessed in, let's say 5 millimeters or something, that's not going to work for us. So if you need to get a little bit of height around your model, you'll want to play with this setting. So do that and just play around with the other stuff as well. I tried playing around with base stand depth and I didn't get very far with that. I wonder if that's for how thick the material is. I don't know. We'll see. You can play around with the curvature. There's a bunch of stuff here. Play around with it. Anyway, the key thing to take away from this is that when you go through this process, I suggest you create 2 models. You create the model that you want to print that's got the high resolution, all the triangles that you want, that your printer and a laser or CNC might be capable of working with. And then, because of the way in which Fusion works, it doesn't like tens and thousands of triangles, and this detailed model here is made up of exactly that, lots and lots of triangles. It doesn't work very well with that. So what you should do is create a second model which has got low resolution. And so what I'll do right now is I'll create that first model with all the details you could ever want to print in CNC, and we'll save that almost 16, close to 16 meg file. Oops, double clicked, and that's going to open up in Cura now. So I'm going to call this high. All right, and now I'm going to go back to the Lithophane app and I'm going to go into settings, model settings, change the vectors per pixel to the lowest value possible. I'm going to try 0. Get some divide by 0 thing or something like that. 1. Go down to 1. Do a refresh. And you see how now it's blurry 60s Star Trek kind of vision there. It's pretty blurry. We'll save that and we'll rename that to low. Or ensure that the name has low in there. And you'll notice that the size of it is less than a meg now, right? So 16 times smaller. That's a lot less detail, a lot less triangles. It's going to be easier for Fusion to process. All right, let's copy those downloaded files to like the project folder where I'm gathering everything for this. And we're going to work with that low resolution model. So in Fusion, brand new document, haven't done anything. First thing we'll do is just insert that mesh. So we can select that. And when you insert an STL mesh, you'll be able to maneuver it around if you want. You could, rotate it, whatever, transform it. You can always do that later on. But after you set OK to insert in the model, you'll want to convert that STL mesh into a solid body because it'll be easier to manipulate and do stuff with. So let's do that. And the way we'll do that is go to, because it's still an STL mesh of triangles, let's convert that mesh from the mesh options, modify, convert mesh. There's different things that we can play around with here, but I'll just go with the defaults for now. Cool. Now, because it was only a 1 meg model as opposed to a 16 meg one, it was 16 times faster. Believe me, it would have been a much slower operation. And because we have, in this model, we added that border all the way around, when we zoom in here and we have a look, and I'm using the shift and middle mouse button to kind of orbitally rotate this around. You can see we've got the bottom is not like one solid piece, it's actually made up of lots of little triangles, right? And that's just the nature of how the STL models are defined. What we're going to do now is, and I can move things around manually, or in the top right, I can just click on the different faces of this cube here. And you can see we have not just the curve of the bottom, but when we look at things dead on, we're also seeing these bumps caused by other details of the lithophane. Now, what we could do is just kind of make a note of the actual curve that we want our stand profile to have, or we can, slice up the model in a way where that's not a distraction for us. And so I'm going to do that because let's say we had a shape that was kind of unusual at the bottom. It wasn't just a straight curve. It would be easier if you were just able to focus visually on that piece. So either way, we have to, in order to create our 3D stand, we have to start, you don't have to, but it's easier if you start with a sketch, right, with different profiles, which you can then push and pull, extrude solid bodies into existence from. So let's create a sketch. Left click on sketch, and the way most operations work in Fusion, when you select an operation, you'll have to select the thing, the surface, the body that your operation is being applied to or is going to be relative to. So this is I just left clicked on just one of the triangles on that bottom face there, and so now I'm just wheeling, using the mouse wheel to scroll in and out. What we could do is create a 3-pointed arc within the sketch menu options. I can just left click, and you see it's kind of hard for me to figure out exactly where to click. I can zoom in like almost infinitely, right? And you see it's slightly off, but it could be good enough for this job if you don't need things to be super accurate. What you could do is exactly this. You just zoom in and out, and just get as zoomed in as you're comfortable with. And so that's one way to go, right? I've created a line that represents the outer edge, and I could do the same thing for the inner side as well. So, and I could create a profile that's closed, and then I can turn that 2D sketch profile into a 3D object. So that's one way to go. Another way to go, if I just undo that, is to take advantage of the fact that we have this model and actually project the geometry of that body onto the sketch that we're working with. And so if I use it's buried in the menu somewhere, but if you want, you can at any time just press S and that'll bring up sketch shortcuts, and here I can look for things. So there's this operation called project, and what project will let me do is, let's say I want to have like a super precise profile being created, right, based on the geometry of the object that we want to be recessed in the stand. What I could do is go through here and I could one by one select all the triangles, or just the most significant like outer edge or corner points of an object. And what I could do is just select those and then say OK. And what that operation did was take the 3D shape and project those points onto the surface of the sketch that we're currently editing. And it didn't kind of look any different, right? But if imagine, well, don't imagine, just have a look. There's also these other details here that are some way down in the model. Well, I can, using that project operation, I could have, for whatever reason, I could have taken those either edges or points or full surfaces. In this case, the surfaces are just triangles, but there could be other shapes too. I could take those surfaces, and I don't know if you can make that out, but this is a projection of that 3D object onto the 2D sketch, right? And so that could be useful for situations where you don't just have a simple curve, but you've got like feet at the bottom of a model, and those feet are not perhaps perfectly standing. Maybe there's a curvature, or there's a chamfer or something, right? But you're recessing your materials, your stand needs to be able to accommodate that. So that's something you can do. And there's a lot of triangles, right? So it's going to be a pain to do that manually. So another thing we could do instead of projecting individual points is to just project the entire body of the object. So again, I'm pressing P, the shortcut for project, and I'm going to tell Fusion I want to select the body, and I could left click, I think, on here or here, and you see now we've got the entire body being the profile of that being selected. And that might be good for certain situations, but not ours, right? We don't want to create a stand. And let me just visually represent the stand. Let's say we have, this is our stand. We'll fit dimensions of this later on. Let's just give it a bit more space so it's not a distraction. So we could do it this way, but I think actually what would be nicer to get a perfect profile of that bottom section of the lithophane would be if we kind of hide some of these details, or just ignore these details when we're doing that projection. And so one way to do that is to actually back out of this sketch. And I'm going to take this, you see every time we do an operation, it gets appended to the timeline at the bottom here. I'm going to drag that over, left mouse button, and before we create the sketch, in fact, I'll just delete it altogether. So I'm right clicking and just delete all features after the history marker. So that would just wipe out anything. It's like a undo with no opportunity to redo, right? So what I'm going to do here now is I'm going to split this cat up, this upside down cat. So let's get that right side up, just for no other reason other than just, yeah, OCD. So let's create, in Fusion you can have these virtual planes, surfaces, which are useful for using to do various operations, but don't actually change the physical model. So this construction plane I'm creating is an offset plane, so I can create that and give it an offset from the surface that I selected it. So I'm going to just, it doesn't matter too much about how far I go. What I'm trying to do is just create a surface which we can then use to split the model across. Imagine this is like a blade that we're going to slice through the material, and we're doing that because we want to project just the bottom section or that curve onto the sketch, which we'll be using to create our stand with, against. So I'm just going to say okay to this. So that didn't change the model anyway, it just created this virtual construction plane. But we will use that plane now as a tool to split our cat body. Splitting tool, I'm selecting that, okay. And I'm going to say okay. And this would have taken a lot longer if we had a lot more triangles in that model, and that's why we're using the low resolution version. And so now in this browser view on the left, as I hover over the models, we can tell which is which, and I can just hide that for now, so that, and let's also hide the construction plane. And you know, I could have had many different construction objects in here, not just planes, there's other things too. With that hidden, but remembering that this is the bottom, let's now create our, and I don't know if you noticed, but the model is actually simpler. There's less triangles, and even the bottom is a solid surface as opposed to made up of triangles. So that simplification of the model, of the geometry, is great because it will actually help, I think, make Fusion more responsive to work with. So we have less triangles overall because there's less of a shape to work with, and then there's less triangles even for the part that we are actively working with. And so now this will be nice and fast to use. So let's again create a sketch, left mouse click on the bottom surface of that triangle, and now we're going to do a projection, and it looks like, because that automatic merging of those triangles into a single, Fusion was smart enough during that previous split operation to recognize, oh, it could just opportunistically merge the triangles into a single surface. It was able to do this. If it didn't, and you still had lots of different triangles, well then you could use, oh, well, you know what? I had bodies selected. Let's see if that still works, what I just said. Yes, okay, still works, everything I said. If it didn't, if you ended up just with lots of little bits, again, you could, with this small part of the overall piece that you're working with, you could select bodies, and then whatever you see would be projected onto the surface, the plane of the sketch surface that you're working with. So now that we have that, we've got a profile, and it was created pretty quickly. And now let's start to create the outline of our stand and get it to a point where we can, you know, save that off. Ultimately as a DXF or something that we can throw into a different tool to work with for creating the tool paths for the CNC laser, whatever. All right, so I just selected rectangle, left click one corner, left click on another one, just arbitrarily, not caring too much about the precision, because what we're going to do is achieve precision by adding dimension constraints to after the fact. After you've created your arbitrary shape, you can add more and more constraints to get things to be exactly the way that you want them to. So I'm going to I've clicked on dimensions, so I've clicked on one edge and now another edge, and I've got this dimension. So what this lets me do is say, I want the distance between these two lines to always be 40 millimeters. Or I could have said 2 inches, right? Inches, millimeters, you can do use the units in that dimension constraint. Another way to do this would have been just, instead of selecting two edges, well, these two lines of the rectangle are perpendicular. When I drew the rectangle perpendicular constraints between those lines would have been created as well. I could have just selected this line here on the side and said, hey, that should be, 40 millimeters. So that's another way to do it. So many ways to do the same thing in Fusion. So let's put a constraint here too on the length of this. Let's make this guy, I don't know, 110, right? And then let's center everything up as well. So one way we can do that is create kind of construction, like virtual lines in the sketch as well. And we can do that by first of all just drawing a line. And one of the nice things about Fusion is when you hover halfway over a line, you see a triangle that tells you at the midpoint, and that's useful for being able to draw a line perpendicular to or from the middle of something to some other point. Could be also to the middle or to some other area, whatever. And then I'm just going to just press escape to get out of line mode, and I'm going to select left click on that line and turn it into a construction line, because I don't actually want it to be dividing the object. I want to be able to just select that entire object. If I didn't do that, I'm just undoing just temporarily. If Control Z, now with that being a normal line, these end up being two separate regions, profile regions that I would have to remember to select when I'm doing something. So I'm going to redo that, Control Y to redo the operation. So this is one region still. And what are we trying to do? We're trying to get the profile to be placed symmetrically within this rectangle. So I'm not sure if this will work, but I'll try it. So I'm going to select one point, second point, the extreme points that are mirrored, and then I'm going to select our construction virtual line there, and that didn't seem to like it. Okay, all right, let's try this try the same thing again, expecting a different result, except this time it worked. I'm not sure what I did wrong the first time, but okay. Let's just back out, Control Z. Let's do that again from scratch. Select symmetry, you select one point, and then your opposite point that you want to have mirrored, and then if I stay still long enough, it'll say select a symmetry line. So I'm selecting this. Okay, so that, all right, that works. Now, we want to also be, I guess we could do it. There's different ways to do this. I'm thinking about how we can vertically get this arc in the middle, but then I'm also thinking, well, maybe you don't actually want it to be perfectly in the middle. I don't know. You could play around with it. Different ways to do it. One way to do this would be just, maybe you want a certain border to be maintained from the front and the back. So what you could do is say, hey, let's have a dimension constraint from one of the frontmost points of this profile to one edge, left click, and I'm just going to leave this as is for now. Actually, let's set this to 10. Just 10 for now, and we can play around with it. So what we can do here is do the same thing, create a dimension constraint, and because we've constrained, like once you've got quite a few constraints, you have this thing called overconstrained, where like I can't add a constraint that has an explicit value without that breaking one of the existing constraints. So we're in an over-constrained state. So the best it can do at this point is just say that this constraint is driven by all the other constraints that you've already defined. And that's fine, there's nothing wrong with it. We can see what we have here. Now I could finesse this by, I'm going to press escape so we'll get out of dimension mode. I could finesse this by hand and say, okay, that happens to be almost 11, right? So I could just set it to 10.5 and like good enough, right? Similarly, because we have constrained the horizontal location of this to be symmetrical to the vertical construction line, if I was to add a dimension from the extreme edge to, you know, any of these points on a horizontal plane, we should find that that also is over constrained, right? Because we've already put in enough constraints that you couldn't explicitly specify some value without that break prior constraints, and that's fine. It's actually worked out pretty good. Just kind of sheer dumb luck that these units ended up being pretty equal. I didn't mean for that to be the case. Let me just mess things up a little bit and end up with an uneven set of values. So you see, because we've set up these symmetrical constraints, we have this vertical line in the rectangle that's halfway, and we said that the profile needs to always be symmetrical to that. That it doesn't matter how wide or narrow I make the yeah, I'm just left clicking on the dimensions to be able to edit them. It doesn't matter how wide I make the width, it will always maintain the profile will always be in the center of that, which is kind of neat. So let's go down to 110 because that seems to be pretty good. Over here, actually you want to maybe have a bit of a border because we're going to add some roundedness to this. Let's make this a silly large value just to emphasize the point that this is not constrained vertically. Let's get this profile to be vertically centered, right, given whatever depth that we're going to have for our stand. Something I want to clear up though, I think I've been using the wrong terms. So when I select this sketch dimension here, it will add a dimension that may or may not constrain the model. So we have here, you know, these curved brackets around the numbers. That indicates that these are driven constraints. They're observing, they're measuring, they're not dictating or specifying, setting what the distances or angles are. So I just want to make that clear. Anyway, let's get this vertically spaced. So the way we're going to do that is kind of interesting. We're going to add another dimension that will measure the vertical distance between the lowest point here and the highest point, which represents the front or the back. And the way we're doing that is by adding another dimension, and then it's ambiguous, right? What kind of dimension are we going to have? Like the distance between them, or as I move around, you can see we could have the horizontal or vertical distance being measured. In our situation right here, we want to measure the vertical distance between those. And because that profile is pretty much set, right, this dimension that we add will be just observing the distance. It's not dictating or specifying the distance. So that's an important point I want to try and make clear, because I think I was less clear earlier. Okay, and so the reason we did that is because we're going to now change this distance, this dimension that is a constraint that's saying how far things should be. We're going to change that from being an explicit number, just double left click to be able to edit that. We're going to delete that explicitly typed in number, and we're going to create an equation that references these other dimensions that are a mix of specifying and measuring. And what we're going to do is to have there be an equal distance, work out the depth, subtract from that whatever this size is, single left click, and you see I'm writing an equation here, right? and I'm going to divide that distance by 2. Now I need to put that equation in round brackets, right? So that we're dividing the overall difference between them by 2 and not just, you know, this thing by 2. So let's do that. And now we have a perfectly, well, good enough vertically centered profile. And if I play around with the dimensions, you know, of the depth of our stand, you can see that it maintains that vertical centering. So that's kind of nice. Now I think one of the last things we'll do here is just add rounded corners onto this profile before we turn this profile into extrude it out to be an actualized 3D object. I would suggest that if you were looking to create a 3D model to print, that you wouldn't add rounded corners at this stage. But because I know that this is going to be CNC'd from wood, adding the rounded corners here is the right thing to do, because we're going to take this profile and export it as a DXF, right, for XLCAM or some other CAM toolpath generating tool to use. So let's do that. I'll just left click on each of the corners. And it looks like we've messed up one of our constraints. We'll test that, see if that's a problem. Let's just put 10 in here for now. And let's just test whether we broke something when we added those corners. Let's change the width and height to something else and just see if something, oh, we did break something. So it looks like this line here, this horizontal line, didn't stay. So we must have broken that constraint that kept this guy centered, this vertical construction line centered. But we should hopefully be able to fix that, because you can remove this construction line and create another one in the new center of our, move too far. Okay. So I'm pressing escape, selecting a line, selecting construction. I'm going to recenter. Oops. Just want to be consistent with where I'm selecting the model. Okay, cool. So I've added the dimension, the symmetry constraint again after I recreated the center vertical line. So now as we change the dimensions of the length and width, we can see, you know, that takes effect. We could create some parametric parameters in solid modify, change parameters. There's stuff here you can do. You could add something like length and width, right? And we could set that to like 120, and let's add a width parameter as well. So set that to just 60, right? And what we could do then is to change this to be a parametric model. We could start now that we created those parameters, we could start to reference those parameters. Whoops. I started clicking on other things and it's added those the names of those other dimensions in here. I need to get rid of that and hit enter before I start going over to select other things. So let's change that to width. Okay, cool. So now if I wanted to, I could just, let's say I'm churning these things out and I need to change the parameters every so often. You know, I could just come into the parameters. Come on. Parameters dialog, change some values, and then the model could get updated correctly, assuming I've got the correct set of constraints defined for all the different sketches that make up the model. Okay, cool. Should clarify, you can reference parameters when you're doing other 3D solid operations, not just sketch operations. All right. Okay, so we've got that. Let's also add an offset here within the sketch options, there's this thing called offset. So let's add a gap around the profile. So I'm going to hover over just any of the lines that make up that profile, and because chain selection is checked, in the entire chain of edges connected together will be automatically selected. By default, you get a positive 1 millimeter offset that's created. If the offset that Fusion guesses is not on the right side of where you want it, you can change this to be negative, and then it would be on the inside. So that's not needed in this case. I'm just going to put 0.5 here, but just, you know, let's say we did want, for whatever reason, tighter tolerance, but tighter gap than what you could do. You know, you can do all sorts. So let's just keep this as at 0.5 millimeter all the way around. That's each side. So we got our profile, and that is in there. So what we can do now at this point is just save this. And let's say this was good enough, right? We could take this sketch and just save it as a DXF to our local machine. Here's one I created earlier. Yes. Okay, there's that. Let's just have a look at that. So is that a nice stand? Let's turn this into a 3D model and see how try and visualize this thing. So we've created the sketch. Now let's extrude it, actualize it into being an actual thing. So the way we're going to do that is look at it from the front. Lithophane of the cat is kind of growing on me, actually. This might end up being a real thing. So let's use extrude to let's create the bulk of the base stand and go from there. So there's this extrude function, and I'm selecting the profiles of the sketches. I would only see those if the sketch was visible. If you don't see the sketch, you won't be able to select the profiles. So right now I'm going to again create the bulk of the body, and I'm just left clicking to select all those profiles. If I didn't, then if I was to maybe make this be 10 millimeters thick, if I didn't have those pieces selected, I would end up with a 3D shape that is not like complete, if you will. And you know, maybe this is okay. Maybe you're okay with the whole thing being hollowed all the way through, but probably not. Probably you would want to have just, you know, a recess of a few millimeters. And although you could just create such a thing using just the DXF, since we're trying to visualize this thing, let's just go to the trouble of doing that 3D model in here. Something I also want to fix up here is that the body was created, the stand was created, you know, just underneath the bottom of the model, and that's not quite right. What we want to do is have the shape be just slightly offset from, because we want the bottom of the lithophane to be embedded inside. So what we can do is, instead of using the default profile plane or whatever, we can change to use offset, and I can put in a number here. I want to pull this up, just the start of our object, just a few millimeters, 3 millimeters, right? And by default, I think join is selected. You want to make sure this is a new separate body from the existing body, so make sure new body is selected. So yeah, we're going to extrude, we're going to actualize, create new material 3 millimeters up from where the sketch was defined. The sketch was defined at the very bottom of the lithophane, and it will be 10 millimeters thick. Yep. Okay, let's do that. And you can see it's kind of hollowed all the way through. But what we'll do is another extrude. There's multiple ways to do this. We could make the whole thing solid and then cut out a bit, or we can just do another separate extrude and have this second extrude just be a portion, a slice, and have it join to that new stand. Let's try that. So I can't see the sketch, so I'm going to display it. And because everything's all now 3D, the sketch will be based off of the bottom of the surface that we first defined it. So I'm going to select, I just left clicked on both of those. And we'll do another offset again. But what we can do to help simplify the math is show the body that's here, and there's a little trick. I can just select this surface, right? And that tells me, okay, 7 millimeters is the distance between the sketch, the plane of the sketch profile, and the bottom of the stand. What we can do is do an offset, extrude, say that it's 7 millimeters. That's the start of the extrude, right? And then we can change the distance to be negative. We could have, you know, maybe we want 5 millimeters of material. We can make sure that this is a join operation. It shouldn't be cut because there's nothing to cut. It's just air gap, right? So here we do a join, and now we've got that defined. And if we were to go too far and join too much, we'd end up joining the cat. And let's say we screwed that up and did exactly that, right? Let's say we had -9. Okay, so what happened there? Now, when it did that join, it actually joined the base and the bottom, right? The bottom of the lithophane has disappeared now because it just got merged in with the standard, one and the same. And what we can do is, that should happen, is edit that feature and, oh, well, I was hoping in here it would tell us the objects that it was going to join. And we could explicitly say not to join those objects. Sometimes you see, that's unusual. All right, well, we'll just fix that. Usually you can see the list of objects that it was going to join in these checkboxes, and you can deselect the ones that you don't want to be selected. All right, whatever, it's not there right now. All right, so you see I've just changed that distance to be 5 millimeters. So now the bottom of the lithophane is still its own separate thing, right? Cool, so I'd say that was pretty good. If you want to play around with the look and feel of these things, it's easy enough to do. Yeah, you can right click, select appearance. I think the appearance is in one of the options here. You know, you can have things look like wood, metal, plastics, whatever, all sorts of stuff. If you go completely clear, then you might not see anything. So I don't know, like maybe frosted or something like that. You can edit the materials. There's a lot of options. Rendering settings, sure. You don't need to have the lines. You could just have it be shaded. So that's yeah, that's an option. We can you can change stuff. I'm not going to go into it. I think that's kind of good enough for now. All right, cool. If you need to export any of this stuff, you could export the entire thing as an STL, save as mesh, save locally, create the STL. Another way to do this, let's say you just want the stand. Let's just rename that. Good to just like check, deselect, you know, your stand model object. You can just right click, save as mesh for that guy. And so let's just say we have that. Okay, save in local, replace it, sure thing. And now we can go into Oh, it's not there anymore. I have to just pull up the browser window. Let's find the folder that those files were saved to. So here is the standard STL that we just saved a few seconds ago, and double click on STLs. I've got things set up so Cure opens up. And so yeah, you can see that might not be on the bed automatically, just because of the placement of where we, and the orientation of where we created the models and the infusion. But that's something you can play around with and fix. You can redefine your coordinate system. Another video. All right, cool. I hope that helps.